Hi everyone, and again welcome back. Today we're going to have a look at Theorem 5, and Theorem 5 teaches us that the opposite angles of a cyclic quadrilateral are supplementary. In other words, the opposite angles together will give us 180 degrees. Now for many of you, it's the first time that you hear about the word cyclic quadrilateral. All that this means is that we are working with a quadrilateral, but the angles are on the circumference of the circle. And it's the same for this one. Look, here we have quadrilateral A, B, C, D, but the angles are on the circumference of the circle, which makes this quadrilateral a cyclic quadrilateral. Now, this theorem teaches us that the opposite angles, in other words, angle A, plus its opposite angle, angle C, together is 180 degrees. In the same way, angle D plus its opposite angle, angle B, together is 180 degrees. And it's the same for this figure. So angle A plus its opposite angle, angle C, together is 180 degrees. And angle D plus its opposite angle is 180 degrees. Now let's go and look at the theorem and why it is like that. Now we are given circle O with O the center of the circle and cyclic quadrilateral ABCD. Now this proof is the same for both these figures, so you can follow along in both. Now we want to prove that angle A plus angle C is equal to 180 degrees. Now I'm going to stop here quickly because sometimes they just ask us to prove only one pair of opposite sides are equal to 180. If that is the case, I quickly want to show you something very important. If they ask you that angle A plus angle C is 180 degrees, in our construction, we are going to connect the center of the circle with the other two angles. So we're going to connect the center of the circle with the other two angles. Got it? If they ask us angle B plus angle D is 180 degrees and we only have to prove this pair, well, in our construction, we are going to connect our center with the other two angles, not the ones that they ask here. Got it? So again, if they ask us to show that angle D plus angle B is 180, we are going to connect our center with the other two angles. Now, in this case, they ask us to prove both pairs, and because they asked this one or they mentioned these two first, I'm going to connect the center with the other two angles. So our construction, we're going to connect our center with angle B and O with D. So here we go. O to D and O to B, as well as in this figure, O to D and O to B. Okay, got it? And now we can start our proof. But before we start, I'm going to name this angle O1 and this one O2. I'm going to do the same in this figure. This is O1 and that is O2. So here we go. Angle O1 is equal to 2 angle A's. Now why is that? Why is angle O1 2 times this angle A? Because this is the angle at the center, this is the angle on the circumference, and both these angles are subtended by this arc DCB. So angle at center is 2 times the angle at the circumference. Now we can do the same with this angle. This is O2 and this is going to be twice the size of angle C. Now why? Because the angle at the center is 2 times the angle on the circumference, because they're subtended by the same arc DAB. Now it's the same for this figure. Angle O2 is going to be twice the size of angle C because both these angles are subtended by DAB. Okay, so here we go, and we can say angle at center is 2 times the angle at the circumference. And now what we're going to do is we're going to add these two together. So angle O1 plus angle O2 is the same as angle 2A's plus 2C's. So angle O1 plus angle O2 is equal to 2, and I factorized already, so I took out a common 2. It's 2 times angle A plus angle C. Now look very closely. When we take angle O1 plus angle O2, we have to get 360 degrees. Now why? Because these are angles around a point. Okay, and this also, so it's angles around a point. So angle O1 plus angle O2 is equal to 360 degrees. Now if O1 plus O2 is 360 360, and that is equal to 2 times angle A plus angle C, then angle A plus angle C must be equal to 180 degrees, because 180 times 2 must give us this 360 because they are equal. So that means angle A plus angle C is equal to 180 degrees. There we go. So we proved this first part. Now what about the second part? Now we're simply going to say that angle A plus angle C plus angle B plus angle D is also equal to 360. Now why is this like this? Because the interior angles of a quadrilateral is equal to 360 degrees. It's true for squares, parallelograms, trapeziums, and we can continue like that because the interior angles of a quadrilateral is 360. So we write that down as our reason, the interior angles of a quadrilateral. Now, if A and C is 180, then B plus D must also be 180, and therefore angle B plus angle D is 180 degrees, and we proved the second part. Now, what do we learn from this theorem? When we are given a cyclic quadrilateral, doesn't matter what it looks like, as long as all 4 angles are on the circumference of the circle, we know that the opposite angles of a cyclic quadrilateral together is 180 degrees. So we use this as our abbreviation if we want to prove that these angles are 180 together. See you again next time. Bye.